Example 4, finding the extrema on a closed interval. Again, we know that if we have a closed interval, that we're going to have an absolute max, absolute min. So let's see if we can find that. Here is our function. Okay, and here is our closed interval from 0 to 2 pi. Okay, we know that the extrema will happen, okay, occur either at the endpoints or the critical numbers. So we already have the endpoints. Now we just need the critical numbers. So to find the critical numbers, first we need to take the derivative of this function. So the derivative of 2 sine of x would be 2 cosine of x. And the derivative of cosine 2x would be negative sine 2x times 2. So f prime of x equals 2 cosine of x. This would be plus 2 sine 2x. Okay. Now we need to figure out the x values where the derivative is equal to 0 and where the derivative does not exist. Well, x values where the derivative does not exist, that doesn't come into play here because the domain for the cosine function and the sine function are all reals. So there's no does not exist values here. Okay, so notice right here, this guy here, this sine of 2x. Hopefully you remember this trig identity. This is something that you should have memorized in trig. Sine of a plus b is equal to sine of a times cosine of b plus cosine of a sine of b. Or another way to think of this is sine of x plus x, which would be equal to sine of 2x. So if we apply this, this would be sine of x, cosine of x, cosine of x, sine of x. So this is 2 sine of x, cosine of x. So now I'm going to be able to replace this with two sine x cosine x. So this would be 0 equals 2 cosine x plus 4 sine x cosine x. And then I could factor out 2 cosine x, leaving me with 1 plus 2 sine of x. I could divide both sides by 2. So I've got 0 equals cosine x, 1 plus 2 sine of x. Then I could take cosine of x, set it equal to 0. And I could take 1 plus 2 sine of x, set that equal to 0. So this would be, let's see, sine of x equals negative 1/2. So now I need to figure out the x values that make this true. So think about the cosine function. It's going to look like this. And cosine of x is going to equal 0 here and here, which would be pi halves and 3 pi halves. So when x is pi halves and 3 pi halves. Let's look at sine of x. So negative 1/2 is going to be here and there. Okay, so we have to figure out what those x values would be. So if you think about what sine of x is equal to, that's equal to opposite over the hypotenuse. So I'm going to use x squared plus y squared equals r squared, where I'm going to call the opposite side negative 1, the adjacent side x squared, that should be equals, and r squared would be 4, which is 2 squared. So this is going to be x squared plus 1 equals 4, so x squared equals 3, so x equals plus or minus the square root of 3. Okay, so now I'm basically looking at a triangle here. Well, on the unit circle. So let's see. The opposite side is negative 1. The adjacent side is the square root of 3, or negative square root of 3. And the hypotenuse is 2. So since it's the unit circle, I want to make this 1, so I'm going to divide everything by 2. So this reference angle in here must be, let's see, 1/2, that must be 30 degrees, which is pi over 6. So that means this angle here would be pi plus pi over 6. So pi plus pi over 6 is 7 pi over 6. And this one angle here, this would be 2 pi minus pi over 6. So this would be 11 pi over 6. So now all of these are all critical numbers. So the critical numbers are x equals pi halves, 3 pi over 2, 7 pi over 6, and 11 pi over 6. And then my endpoints are at x equals 0 and x equals pi halves. So the function is 2 sine of x minus cosine of 2x. Now what I need to do, I need to take this information and plug them all into this to see which one is the maximum and the minimum. So let's do f of 0 equals 2 times sine of 0 minus cosine 2 times 0 would be 0. So we know sine of 0 is 0. And we know cosine of 0 is 1, but we have a negative here, so this will be negative 1. Next, let's try f of 2 pi. So this would be 2 sine 2 pi minus cosine. 2 times 2 pi is 4 pi. So sine of 2 pi is 0. Cosine of 4 pi is going to be 1, so this would be negative 1 again. Let's see. F of pi halves is going to be 2 sine of pi halves minus cosine. 2 halves times 2 is pi. So let's see, this would be sine of 2 times sine of pi halves would be 2 minus, let's see, cosine would be negative 1. This is going to end up being 3. Let's see, f of 3 pi over 2 equals 2 sine of 3 pi over 2 minus cosine of 3 pi. So sine of 3 pi over 2, that's going to be negative 1. Negative 1 times 2 is negative 2 minus cosine of 3. So that's 1. So it's going to go back down to negative 1. So this would be negative 1. So this would be negative 2 plus 1, which would be negative 1. Then I've got f of 7 pi over 6, which would be 2 sine of 7 pi over 6 minus cosine of 11 pi over 3, because you have to take 2 and multiply it. Oh, did that wrong. When you do 2 times this is going to be 7 pi over 3. So let's see. So this would be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. Okay, so sine would be the opposite, which would be negative 1/2. So this is going to be 2 times negative 1/2 minus, let's see, 7/3. Okay, for the sake of time, these two last ones, after you calculate them, they're both going to be negative 3/2. So now you can see here that this one would be our max, and these two would be the minimum.